الشيطان الرجيم بسم الله الرحمن الرحيم اللهم صل على سيدنا محمد وآله وصحبه وسلم. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the Safina Society podcast. How are you guys doing today?
Alhamdulillah. Good.
Alhamdulillah. So today we are joined by Professor Zahid Hasan from Princeton University. So how you doing?
Alhamdulillah.
Alhamdulillah. How's your drive up?
Not too bad. It's traffic hour.
Yeah, you want to tell us a little bit about your background? I think you were at Princeton for almost 20 years, and you were at Stanford before that.
I'm a physicist, and much of my last 20-year career is into quantum physics.
MashaAllah, MashaAllah. When you say quantum physics, the way that I and most lay people understand quantum physics and what we know about it is like Ant-Man from like the Marvel movies, or going through time. Mostly what Bollywood, Hollywood and movies have represented to the world, right? So why don't you give us a very, very simple explanation of what quantum physics actually is?
So one way of understanding the difference between quantum physics and non-quantum physics is that within quantum world, which deals with the smallest objects like particles, electrons, and very tiny particles, turns out that the physics is somewhat different in the sense that you have certain degree of uncertainty in knowledge about the state of these particles, how these particles move. Their velocity and position may not be accurately known at the same time, or time or energy may not be known at the same time. So these uncertainties are apparently missing in the classical world, or you can ignore. So the most remarkable thing in the quantum world is that there is some level of intrinsic uncertainty. It's not something. It's not about our lack of measurement capability. It's about intrinsic uncertainty. Yeah.
So when you say intrinsic uncertainty, is that, for example, like the location of an electron?
Yeah. If let's say if you know the velocity precisely, then the location becomes less certain. I mean, you have less knowledge of the location, or if you know the location with a high degree of certainty, then the velocity becomes less certain. So the main idea is that there is some intrinsic, inherent uncertainty in the knowledge of a particle. So that's the main difference between the macroscopic world and the quantum world.
Okay, I have two questions. Firstly, when we speak about small, we're talking 10 to the negative what power?
10 to the negative, say, 15 meters. So it's like billionth of a billionth of a meter of microscopic objects.
Okay, my second question is, when you say the intrinsic uncertainty could be of the location of the particle, then what else is allowing you to measure it? If you don't know the location, how are you even measuring it to begin with?
So typically, we measure location or velocity by shooting another particle. It could be a light particle, light ray, or another electron, or another neutron, another quantum particle. So only a quantum particle you can use a quantum particle to see another quantum particle. You cannot measure with a bigger object, right? So, and then when you try to hit that quantum particle with another particle, then you don't know what the original particle was doing in the beginning. That does not appear, that does not complicate things in the bigger world. So you want to measure where your laptop is, you shine light or throw something at it, but the laptop is not moving, and so you know accurately where it was.
I see.
But it's in the quantum world, it's a little more than that. I mean, that's part of it, but it's also there is an intrinsic, if you like, it's going back to the Greeks. The philosophers ask how much of the absolute truth you know. It's about a hit on the absolute truth. There is no way of knowing it. It's not that there's no way of measuring it. It's no way of measuring it because there is no way of knowing it. So it's more like intrinsic, if you like, philosophical.
Yeah.
At the philosophical nature of truth level,
right?
The truth itself becomes uncertain, at least from a physicist's point of view, from a scientist's point of view.
Yeah, no, I was just going to ask: is the uncertainty because is it a consequence of the observation, or is it what you're seeming to say is that it's both a consequence of the observation as well as some inherent uncertainty
so
within
it turns out that in the quantum physics world, you only believe in experiments, and the theory comes after the experiment. It's not like we write down something,
Right.
and then that we take it as absolute truth. We do experiments and figure out what is real. So there have been many experiments that seem to prove that it's not our lack of ability to precisely measure something at the quantum world, even though that may partly be involved, but it's also how you interpret multiple experiments in a way that seems to suggest that it's not our lack of ability to measure something, there is an intrinsic uncertainty in the knowledge of the state of a particle. Yeah.
So I have two questions I want to follow up with that. One is more physics-based, but the second question, I'll start with that first, is you mentioned there's a philosophy behind some of these things, and which is when it comes to the world of quantum physics, it's very interesting to hear the words philosophy, right? Because it's philosophy deals with elements of the metaphysical almost, right? It's very interesting to hear scientists, right, who mostly deal with the material world, right, and not the abstract world, and not the metaphysical world. But when it comes to quantum physics, a lot of it does rely on some level of philosophy. I mean, that's how I understand.
So I actually meant I used the term philosophy in a more English dictionary sense rather than a discipline in a department sense. It's like in this actually more. I would say most physicists try to ignore philosophy because then you are subjective in some way. So the main the idea in quantum world is to determine the truth by doing experiment through observation. So they then interpret that independent of any theory or anything else. So I want to make sure that this is not our interpretation is not philosophical. So in some circles, people don't like to use the word philosophy. I meant it in the sense that the ancient Greeks, when they were asking this question, what is real, what is true knowledge, what is absolute knowledge? So quantum physics, the experimental quantum physics, is in some way allowing us to test those questions in some sense. But the result, the outcome itself is not subject to opinion or philosophy. It's telling us something about the rock bottom reality, about the truth itself, about nature.
So then what are the limits, as you've understood as a scientist, of where physics ends or where science ends, and where, whether it's theology or some religion or a personal belief that sort of takes over? What is the limits of
the
that?
goal in physics is to understand the truth about nature, the natural world, physical world. So physical world can be, at a very fundamental level, physicists sort of think about space, time, matter, energy, things like that. Now, let's say if you are talking about objects or concepts that is beyond space, time, or matter, energy, physicists do not feel comfortable talking about that because his or her tools, the way of thinking, conceptual development is confined to space-time. Some event happens, there is a time coordinate that it happens somewhere, there's space, but then there's energy and momentum and all these physical quantities are involved. The goal of physics in some way, or the tendency in physics in some way, is to focus on the observable world, where you can do experiment and test ideas and let the experiment win, in the sense whatever the experiment or observation tells you, repeated observation, then you formulate some concept around it. It's not you come with some axiomatic thing. I mean, you may start with, but then it has to be falsifiable. So a lot of things about spirituality or religion, there are concepts that are not immediately amenable to to the tools of physics. Like you cannot analyze those things in terms of matter, energy, or space-time. So in my personal view, different physicists have different view. In my personal view is that I do not rule out the existence of other things because I'm only limited to talk about things that have physical entity because that's my expertise or toolbox. But this does not mean that other things do not exist. I cannot disprove that or disprove that. So there's a limit, in some way, limitation of this is beyond the scope of physics itself. In my view, physics itself is not ruling out many things. I mean, that doesn't involve space-time or matter-energy.
Okay, so this is actually like, I feel like I'm going back to school because I haven't been in a class that's been, really challenging for a long time, so I'm actually enjoying this. But what I'm hearing from what you're saying is that the basic scientific method is not used. And is that just because the field is so young? In other words...
One can think of it as that, there was a time scientists did not think about energy or matter the way we think about. The term energy was introduced formally in the 1800s. Even the Greek philosophers were not using the term energy. Even Newton's law were derived without the concept of energy. That came after Newton's law. So I also cannot rule out that 1,000 years from now, 5,000 years from now, scientists will not be introducing new concepts that they can use to describe physical phenomena, and that may involve additional variables, additional concepts and quantities. So if we confine ourselves, let's say, go back to the Greeks, and we can see that they if you think about the Plato's cave analogy, that you're seeing the shadow inside the cave, and the real world is out there. So science is evolving. Science was not the same 5,000 years back, and so I personally feel at every stage, at every century or every era, we are again back in some sense into the Plato's cave thing, that we're talking about we're watching shadows and experimenting and observing that and formulating our rules, but then the real true world is out there. And there are other people who might think that there may not exist a real world. It's always a shadow. It's one after another at different levels. So there may not be any rock bottom reality out there. But we also cannot rule out that there is no rock bottom reality out there. Science will evolve 5,000 years from now, and we don't know exactly what science will be talking about. Just as we don't know what we know how simplistic science was 5,000 years ago.
So my next question is, when you talked about Einstein and Newtonian physics, what changed in our understanding of the world when we went from a shift in thinking from Newtonian to quantum physics?
Yeah, this is a very good question. What changed is actually the high precision tools, the engineering tools. So compared to the 1600s, in 1900 or 20th century, the engineering, the tool developed at a higher precision level. So now we can do experiments with higher degree of precision. And it is these new experiments with high precision tools that gave birth to quantum mechanics. Quantum mechanics was not invented based on some set of ideas. It came purely from experimentation and observation and repeated cross-checking. So what I think, so there was a shift in my view from the time of the Greeks, that where you're limited in doing experiments, figuring out the true reality about the world or the universe. But then as our tools have become far more precise, we can we can see, or we can talk about the motion of a quantum particle that's billionth of a billionth of a meter smaller. Those tools did not exist at the time of Plato or Aristotle, so they did not have a way to explore the universe at that microscopic detail. So it's the development of instruments that allowed us to, it's also the microscope that allowed us to see the cell structure, the inner structure of cell, genetics, and all these things came out of that. So it's a precision, higher degree of precision in engineering that gave rise to, gave us access to the deeper world, and also the macroscopic world. Now with bigger telescopes, we can see further out in the universe.
Okay, I have a question on, you mentioned that at a certain point, energy was not a variable.
Energy was not defined or conceptualized. That was only like 200-300 years ago. It was conceptualized after Newton. Newton did not talk about energy. He talked about force, but not energy.
Can you tell us about this variable? Like, how is it objectified, defined, etc.?
Yeah, well, I mean, energy is like, there is a modern definition of energy where energy and mass, they're equivalent in Einstein's definition. The most modern idea is that the matter energy are equivalent through Einstein's equation, E equal mc squared. Mm-hmm. And so in other words, matter is like compact form of energy. It's just release form of energy. So in modern thinking, energy and matter are indistinguishable. And in very early universe, probably near Big Bang, space-time was also not very clearly distinguished. Like you could not tell which dimension is time or space. It's very near Big Bang. But those things are far more speculative. But it's possible that that the dimensions, space-time, matter, energy, everything was some sort of single entity. These are speculative things. But these concepts also evolve. I mean, scientists invent new concept and that find more use. But at least in physics, last 100 or 200 years, it has been mostly dominated by high precision tools that can probe matter or energy or space-time in finer details. And it's forgetting about your personal philosophy or anything. It's about going out and asking what nature is like, and then just take it. I mean, but also that may be limited. Maybe, say, 1,000 years from now, our microscope and telescopes and accelerators would be even will have much better resolution and much more powerful. It will see much finer detail, not just billionth of a, maybe it's another fraction of a billionth, and then we'll understand nature in even farther, deeper detail. So yeah.
So any objective variable has a unit, like length, temperature. So what's the unit of energy?
Unit of energy is like joules, or in modern unit it's called electron volt.
Okay, so power, basically.
It's related to power.
Why are you guys laughing? This is known or something?
It's energy. Power is energy per unit time. Yeah.
Okay, so power, so electricity. But you guys are laughing like
no,
this is something known.
Because I'm being educated, like I'm trying to
it's related to volt. Yes.
Yeah.
Okay, so voltage. I never heard of it being called energy.
But I think all those things that he just mentioned are different things. Like are different. I don't know, whatever variables, like energy is different from power, is different from voltage. Like these are all different quantities that are.
So I was talking about
physical.
Mostly at the fundamental level, microscopic particle level, where energy and matter is indistinguishable in some sense.
Yeah.
Yes.
Yep.
I was laughing because you're a liberal arts guy.
So I did know about wattage and voltage, right? But I never connected that's what they're talking about.
It's related to power in classical units. Yeah.
So I have a more of a question to follow up on what you were saying. You mentioned that as our instruments or our technology that we use to observe these things gets more precision, gets more accurate. And we're able to observe like a level deeper.
Right.
Logically, then, does it follow that you can just always go another level deep, or is there some point where you say like this is the base level that we have we can reach, and
Right.
now we can't really magnify or go a level deeper than that. This is like the basic
Right.
block.
This is a very interesting question. That by itself has to be all experimentally determined. You cannot come up with a theory that the universe cannot, some entity or in the universe cannot be shorter than 10 to the minus 50 or something. I mean,
Right.
you can. So we don't know whether there is a, at this point, we don't believe there is a substructure of electron. Electron is an elementary particle. But then you don't know. I mean, if you have a super powerful accelerator, whether you'll find a substructure. The current belief is not,
Right.
Based on current experiments and standard model. But you never know that 5,000 years from now, you probe much shorter length scale and much higher energy scale, whether there is a substructure of the universe.
So the theologians spoke about that, and the philosophers in India also spoke about this. So just the fact that if anything has a shape, it could be divisible, which means that there could be a smaller particle. So the idea of the atom being the smallest particle, right? So the Ash'ari theologians, what they said is that if it has a front and a back and a left and a right, then it's divisible. It can't possibly be the smallest unit, right? So they ultimately said that there is a smallest unit there because of the belief of the finite nature of the world, but this smallest unit has no dimension. Has no dimension.
It's like a point, yeah. The geometrical point has no. It's a conceptual point.
It's a conceptual point.
So the current understanding, in some way, electron. I mean, there is also experiments being planned whether electron has a dipole moment or not. Those are, as of now, it's inconclusive. So in physics, we don't talk about something that doesn't have experimental proof.
They don't
So
exist.
there are experiments going on trying to figure out whether it's really a geometrical point, the dimensionless point, or it has some tiny dimension, then the electron's charge would be distributed, there will be dipole. There are currently experiments going on like that.
Okay,
so
so-
we don't know at this point.
All right. So you talked a lot. You mentioned computing a number of times, and these machines, and these labs are producing these results, which come out, and we accepting them, but we haven't actually seen. Can you describe to listeners out there, to regular people, what are these machines like? What do they look like? When you go to Stanford, because you go to Stanford like four times a year. You have machines here in Princeton too?
Both. Yeah.
Okay. So just describe it. We have never been into these
So,
places.
so for the very broad audience, let me make an analogy from the biological sciences, right? If you want to see something, then you bring in a light, and the light is reflected off of that object, and it enters your eye, and you see something. So your eye is the detector, and the object you're probing with light. So you shine light, and then you use your eye as detector. So microscope in some way is similar. You shine light, you magnify the image and see it, right? So the invention of the microscope was a revolutionary thing for biological sciences. You suddenly saw that the living organisms are made up of cells, right? And then at some point there was a limit. Okay, so with the light, with optical microscope, you cannot see smaller things than you cannot see the molecules inside the cell. You can see the mitochondria or some structure, nucleus of the cell, but you cannot see how the the molecules are forming DNA strand and all that stuff. So then you need a microscope that has higher resolution. It can more resolving power. So then you can use electrons. In quantum physics, electrons have also waves. So then just like light wave can reflect off, electron wave can reflect off, but the electron wavelength is shorter. So then you can see finer features. So the way to see, say, DNA molecule inside the cell is use a powerful electron microscope type of thing. So in physics, we do a similar thing to see a fundamental particle or some composite particle. Here, so now you can see that if we use light or your probe particle or probe beam, that has shorter wavelength, then you can see shorter, finer things. So light, electron wave is shorter than light. That's why with electron microscope you can see finer details. So in physics, in pure physics, we use accelerators and we create we accelerate particles. Then the particles are quantum objects. They also have wavelength. So then the shorter the wavelength of the particle, then we can see finer details of it. Now, if you go to higher and higher energy, then the wavelength is shorter, so you can see finer details. So you then shoot that particle into some other matter and see, just as you see the details of the cell inside. When you shoot, say, a powerful proton or electron into another particle, you see how the quarks are distributed inside the proton. So it's about, so in a physics lab, we're using high energy beams, particle physics type lab, and then the idea is to probe universe with a wave that has shorter wavelength, so you can see finer detail. This is also limiting us, that we cannot tell whether electron has substructure because it's already a very small thing. We cannot. So that is also limiting. So if you like, the accelerators are also microscopes for physicists.
So like the layman's explanation of that is it's a really powerful complicated microscope
precisely
that we're using to like smash particles together.
Or see particles, or what is inside particles. Yes.
But so when you're saying shooting beams and seeing quark,
inside the protons.
But what does that look like, though? Is it?
So then let's say you have a nucleus, you have a proton.
No, but physically, what does the machine look like?
Oh, the machines are like few miles long. Series of magnets and electric fields. So you accelerate beams. You accelerate some. So voltage. It's like high voltage.
It's like a giant tube, right?
It's a giant tubes where successively you use high voltage, high power electronics type of thing to give particle more boost.
And
so let's say it's kind of like this. Let's say you have
big donut.
You have a positive plate and negative plate, and there's a high voltage. Let's say 10 kilovolt, and then you have a particle here, positive particle. It will be accelerated to a negative particle, and the faster it will go, higher the voltage. Higher the voltage, the faster it will go and hit. So then you can do this. You can try to speed up this thing and then move this, and then to the next one. Then it will speed up again. So this way you can stepwise you can raise its energy. So then you hit something up there, and then by that time, because of the quantum wave particle duality, it also has its wavelength is very short. Now we can see finer details of another particle that is.
And what's the indicator that it hit? And what's the material of the what it's hitting?
It depends on what you are trying to study. You could study gold particle, gold nucleus, or you could study whatever you like, hydrogen or whatever. It's your choice. You take something and then what you want to study. Yes.
And when it hits, what's the indicator?
So then when it hits, then it will scatter off in different direction depending on what it hit. So then from that, you can tell that it hit something that has this much charge, this much mass, and something. So it's like when you have something, you hit something and it scatters off. So there are detectors there. We detect where this particle went after it hit and how it went, what was its energy, what was its velocity. By analyzing those details, we know about the target.
So you don't see the particle, you're seeing the result of the hitting.
Result of the hitting.
So you
don't see the particle.
So you're seeing the residue.
Yeah, you analyze that just as in the in the biology, right? So you don't see the molecules or the atoms or the DNA with your eye. You're using laser. Light. Yeah, you're seeing the reflected light. You're analyzing the pattern. Then you are saying that if pattern is like this, and the target material was like this, it could be something like that.
So that material must be a type of soft material then?
It doesn't matter. I mean, you can study almost anything when your beam is very high, highly energetic.
Powerful.
Then it will go through.
And then is there like glass and then you're seeing these results?
Yeah,
or-
all of this is most
What's the
in
output?
many
Yeah.
cases
Yeah.
it's inside ultra high vacuum. So all the air is sucked out.
Yeah.
And there is hardly any air molecule. So then those energetic particles do not create a scatter signal because there's an air molecule. Then you'll get a wrong signal.
So-
spurious signal, right? So then you make sure that it's all empty. It's ultra high vacuum, and then you heat your target, and then you have detectors all over, and then you analyze where the
You're seeing this on a computer?
you see that in an electronic device that the detector is an electronic device, and then the signal is seen. I mean, it's read out into computer. Yes,
And into,
but it's physical. That signal is generated from a physical hit of the particle on a detector.
and then that, so it gives you an image, almost like an X-ray of what just
Yeah,
happened.
yeah, it's kind of like that.
So you're not looking into this tube, you're looking into an electronic output
Yeah,
interface.
because when you're looking at it, you're always limited by your optical wavelength. Our eye is limited to optical wavelength, so we cannot see something shorter than that with our vision. So then you need an electronic eye,
Yeah.
which we call electronic detector, that can see a wavelength much shorter than that.
And these detectors, therefore, they're scattered all over this
Yeah,
material.
they're arranged all over, so because you don't know which way the signal will move
Yeah.
after it hit.
Okay.
So it's also like, it's very similar to how we see things, that we shine light, so it's all dark room, we
Photon
shine
bounce
light,
off.
yeah, photon, and then it bounce off, it will enter my eye, then the brain is the computer, it will process and create an image, but the detector is the eye.
I see.
So in the particle physics or high energy physics experiment, it's also like that. It will hit another particle and try to see whether it's a bag of three things or a single thing. That way it will bounce off in different way. If it is just bag of one thing, then it will bounce like this, or if there's three things, maybe it will hit the other one, it will go this way. So this way we figure out the inner structure, the details of, and then analyze that pattern.
And the detector is detecting heat.
It's detecting another particle. Let's say it's detecting the proton which has charge or
Charge,
another
okay.
electron. Yeah. So then it will create a voltage in the detector, and how large the voltage is, that will tell us how energy that is, and where it hit, it will tell us the angle.
So I'm going to go a little bit away from the machine. The next question I have is, as I've understood quantum physics, right, the very little that I have understood, the one question that I've always had is in regards to chaos theory and the butterfly effect. Now, in understanding the butterfly effect or the chaos theory, right, is that small changes at the molecular level can have large effects at the macro level. So one thing that I'd like to ask about, because this affects how we as Muslims would understand even reality and things like that. So how do physicists really understand cause and effect?
So the chaos is there can be magnification of a small perturbation into some outcome in the output in a big way, but this is different from quantum uncertainty. Quantum uncertainty is intrinsic. It's just intrinsic limit to knowledge, whereas chaos is a different thing. It's about, in some way, complexity, but there is no intrinsic uncertainty. So in other words, it doesn't, in the old language, physicists don't use that language anymore. It doesn't give us a new philosophy. It just tells you that some equations or some processes are too complex for even the modern supercomputers to give you a reliable result in a reasonable period of time. So it's like practical uncertainty, if you like. You can call it kind of like that, because in my lifetime, I cannot get a very precise answer. But the answer with deterministic precision in principle exists. It's just that you don't have computational access to it, maybe in your lifetime. So that makes it a mysterious thing. I mean, maybe in the weather prediction and climate prediction, those things appear. But then there is also, chaos can also appear in the quantum world. So nonlinearity in the quantum, so that's a different thing. That's a quantum chaos. So that's much more fascinating topic. That's pretty much an active area of research, and I don't know. I mean, there is speculation. The quantum chaos brings in mystery that we don't, many things we don't know. Maybe a new understanding of nature will emerge out of that, because we cannot precisely calculate quantum chaos in certain systems. So my speculation, again, very speculative, that maybe a new idea, a new picture of the reality may arise from quantum chaos. I don't know. I mean, I don't want to connect it to free will or other things, but I'm not an expert on theology or religion or anything. But I'm saying that only in the way where in the frontier of science, say a few hundred years down the line, I think I speculate that something radical may arise. This is one area that something radical may arise.
Like what? No.
It's hard for me to speculate. I don't know, because quantum chaos is a tricky thing. I mean, there's computational intractability and there's also uncertainty there. Together, whether that gives you a new version of reality, I don't know. But let's say, as a scientist, if I would try to pick a direction of research where I want to probe into a new version of reality, maybe that is one area, or it's in some way it's similar to when people talk about, they think about black hole collision, because there's a singularity, is it a black hole connected to the other universe and things like that. I mean, the space-time singularity.
What does a physicist mean when he uses the word reality?
This is a good question. Again,
And what would be like a new reality?
Yeah. So then there may be a new. To me, I mean, these are speculative things, so I can only talk about my own thinking. Say, even though there is uncertainty in quantum mechanics, Heisenberg uncertainty, but the law of uncertainty is deterministic. It's not like the probabilities don't add up to 1. All possible probabilities add up to 1. So the fact that all possible events, the probabilities add up to 1, that law itself is deterministic. So my speculation would be, if we emerge into a new reality, again speculative, it may be that there is uncertainty even at higher level, that maybe laws of probability may not add up to 1 in a simple way. So then there is possibility for totally new emergence.
But what is reality when a physicist says
reality is experiment.
what's coming out? Okay.
Yeah, what is coming out in repeated and reproducible observations.
And how does where's the trickle down to actual lived life? So, for example, in the past, I'm sure we've had the trickle down happens. Like, usually it takes a century before an idea in the mind of a physicist, right, trickles down and actually affects real life, like lived life. So probably usually takes a century. In this day and age, it might take much less than that, because the physicists are now heavily involved in technology, which is used by consumers now.
Yeah.
So, for example, the computing that's going to develop is all coming out of the discoveries in physics departments.
Yeah,
so
probably quantum computing is the next frontier.
So can you tell us about where do you see the next trickle down that the regular person, driving a truck or, cooking in a kitchen, it will be affected by something that's, maybe now being discovered or whatever?
Yeah, so there's a national, at the federal government level, there's a national level initiative, or probably new funding for to push that quantum information technology, quantum frontier. So the idea is to the present day, the Silicon Valley based computers or iPhone you're using, it's using a classical logic. That logic is similar to Newtonian physics logic. You can also say that it's Boolean. The technical term for it is Boolean logic and binary.
Zeros and ones.
Your information is based on that. But quantum mechanics at a deep level, it tells you that the information is much richer. There is a wave function, there is entanglement, and going from bit to qubit, that quantum bit, it's a much richer, it's much richer information system for the broad audience. So then this includes the quantum reality. So the national level initiative is to figure out the technology frontier, how the quantum information can enhance the information system in some way, like it has application in security and quantum internet. And
Have your colleagues have you heard of your colleagues talking about what kind of vision they have of what kind of products would be out there?
Quantum computers at this stage, they are certainly good for some, potential applications, like say accelerating drug design. So there is so much information processing possible that, now we have Tylenol for everyone, but then different people will have different type of long-term side effect for a drug. So then you take your genetic data and then design a drug that fits you exactly in a unique way. So there's a lot of information processing involved. So the quantum
detection.
technology, also cancer detection and
Protein folding.
protein folding, all these
Which
things. Protein folding is probably one of the biggest thing after genome sequencing. It's how proteins fold, how it folds into a right conformational state that does the right functional thing
In your body.
So this is one of the big things in biological science. Another big thing is the connectome. That how it's like doing genomics of your brain. That has not been done because you have more neural systems in your brain that's more than the stars in the galaxy.
Yeah.
So it is a much bigger. It may take 100 years to really map out the brain and talk about if there is a quantum, whether the brain works in a quantum computing sense. These are all speculative things, but some of these things may be the quantum technology may help. Open new frontiers in solving much of these problems.
So that's where
Medicine, technology.
where the discipline meets real life. That's what's important.
Right.
So protein folding is I'm not Googling it. So you might
like one of the big things in cancer research is that like malignancy forms in your body because of proteins misfolding, right? The way your body produces structures when they
Alzheimer and beta amyloid and those things might be protein folding.
And so when they don't fold correctly, that can lead to health problems. And so that's one huge area of study in medicine is like how are these things unfolding?
Actually, I studied some protein folding when I was at Stanford. I used these accelerators can also be used to study biological systems. So these are not just microscope for fundamental particles. They're also that how fast the protein is folding. I can shoot a beam and track what is the conformational state.
So we're talking about assessing or studying what's going on in the human body. What about using this technology to actually affect the human body and fix certain things or remove certain things?
Right.
And now you guys might laugh at me, but I'm thinking if we're at this level of possibly detecting cancers and protein folding, which is at a very what about attacking, removing, shrinking fat cells?
Those things are not out.
That would be a
reach,
huge seller.
And that would really put the fitness industry out of business, right?
Yeah, absolutely.
Yeah.
Okay.
So then, my next question, and sort of, I'm sure this will lead to a much longer discussion, is, what are some of the possible overlaps between quantum mechanics and spiritual realities that we as Muslims understand, right? So some just high level examples that I can think of are things like angelic activities, jinns, and various other types of supernatural phenomenon that we believe in.
I must admit that I'm not not an expert on those topics. So. But let me make a comment. How physicists think about their discipline. Anything that, as I said, is beyond a description of space-time and matter-energy, then it's beyond physics in some way. So then you become a non-expert to those other things, and then my speculation is be as good as anyone else.
Well, I have a question. That's actually connected to this. So let's say this human soul.
So do I.
Yeah.
Afterwards.
Okay. The human soul, for example, it produces heat in the body, right? When a person dies, what happens right away?
It's difficult to define soul.
Let's say an X. It's an X. We call it an X factor. When a human being is alive, Yeah, because just like you said, we're only talking about things that are measurable. So let's just call it an X factor.
Yeah.
When a human is alive, his body's warm, etc. Right? You remove something, right? Let's say we don't know what it's called. You're removing something that variable, and all of a sudden the body goes cold, and then the skin gets soft, and it starts basically dissolving, right, and coming apart. That X factor, is something that we can't talk about because even it's so subtle. But the whole discipline is about probing into the beyond subtle, what is even more subtle than subtle, right? So therefore, that's I think what Moeen is talking about. For example, what we believe as a belief that there exists angels or jinns or whatever, and people actually can sense something, right? Not merely just a belief, okay?
Yeah.
But let's just say hypothetically, these are more than subtle. So the quantum physics field is something that can discover or detect things even more subtle than these things.
Right. I think quantum mechanics by itself, there are many unusual aspects of it. I mean, it creates many counterintuitive possibilities.
Just give us a couple of examples.
Yeah.
Before you proceed, one more point. You had mentioned that in quantum physics, they don't hypothesize. They just do something and see what happens.
Right.
I think I understand things as whenever something's so new, you don't even know what to hypothesize. You just check it out.
Right.
But what I'm saying is now at a certain point, people could afford to hypothesize and say, well,
when you have lots of observational, reproducible experimental data, then you start to see a pattern, then you think maybe this is what is causing it. I mean, that's how medical doctors, they look at symptoms and do some diagnostic test and come up with something. I mean, that's sort of a first guess or target thing, and then you do further experiments to check whether that is the right thing or not. So it's physicists are also doing similar things. I mean, it's not probably in a much more higher precision level because the quantities are already fairly precise.
Yeah, just to give an example, when they doing brain scans, I'm sure in the beginning of the fields, it was just doing things and seeing what happens. But once they got into it, they could do brain scans on Tibetan Buddhist monks. Which I remember reading
there's
that
a characteristic pattern, of meditation.
Yeah, so they can study where that part of the body is meditated is being activated. So that type of research where we do definitely know that something's going on with the Tibetan Buddhist monks. Like, why is he sweating in the snow, for example, right? So there's definitely something going on. And then they, proceeded to go and detect activity in the brain, right, which then affects the rest of the body, blah, blah, blah. So that's, I think, where Moeen is coming through, where eventually a person does possess a hypothesis, right, and then can probe into it, using these, this technology.
Yeah, I'm not an expert on neuroscience or biological science. My understanding is that if, let's say this monks, they're meditating, and then there is a characteristic fMRI signal. It's fNMR, MRI type of functional, and that traces this oxygen level in the brain and find a distribution. There's a characteristic signature. To me, I would personally think that then there is a brain neurological basis for that experience. That does not necessarily tell me it's spiritual. To me, again, it's a personal definition, is that...
Yeah, there's nothing to say
So that means the brain can create, as I said, the connectome is the brain has neuron cells that's like more than the stars in the galaxy, and the way they're connected, it's far from being the neuroscientists they're not anywhere close to mapping it out. So there is so much mystery about the brain itself. Many of these unusual experiences people have, if their pattern is detectable and all that. So first one has to rule out that it's just the quantum physics of the brain network or the neural network system it's already capable of creating many unusual, weird experiences. Some people dream within a dream, and how do you? But that's happening in a. So I'm saying that finding to me, if I can find some experience, unusual experience that is described within the laws of physics that is operating the brain, which is already enormously diverse. To me, that is not spirituality. This is some weird experience. I mean, you can have a brain tumor, and then that can create many strange experiences. Some people do have that. I mean, that's because they don't have a right type of brain. I mean, there's the brain tumor. There's a malfunction in the brain, and that will create all sorts of strange. Some people are colorblind.
Or
It doesn't mean
hallucinations.
the world is colorless, right? So I think to find some sort of what one would like to call scientific basis or non-basis. It's about ruling out all these possibilities that if something is totally beyond quantum physics or the fundamental laws of the neural network, then we can say that this is really beyond the brain activity. Okay, so but then the brain is such a complex network, and its quantum physics and neural network physics is so complex. Its computational strategy is so diverse and complex. It's very difficult to rule out what is truly unusual experience, because all those weird things are usual for the brain. Brain can conceive that. Right?
So I have a question. I mean, that kind of follows on that. So if we're defining a spiritual experience or a supranatural, or
so then
supernatural,
we have to understand nature in great detail,
right?
To rule out that this is extra beyond nature.
But even further than that, right? Like if our observation is limited to what's natural, right? Like if we can only observe by definition what our objective reality is, what our natural reality is, then can there ever be a basis for tracing some spiritual experience to some natural phenomenon? You can't then, right? You can't draw that line from one to the other, because by definition, the spiritual experience cannot be measured or cannot be observed.
Well, I wouldn't even.
I don't know what is the definition of spiritual experience. Right.
That's exactly what I was about to say. I was about to say cancel that whole that whole word, because when we talk about all these things, we actually do believe as a belief that these things are material substances.
Right.
So when a Muslim talks about nur of Allah, light of Allah, like a light of dhikr coming,
These are actual things.
they're actual things, except they're extremely subtle, and their traces are felt, right? So all I was saying is that we do hold that they are physical things.
They have basis in nature.
I see.
Yeah,
I see.
and that they could possibly be detected at these microscopic levels, or beyond quantum levels, I should say.
Yeah.
But we also believe in things that are metaphysical as well, right? So
What is that even?
So-
Like what? I would say this: the only there are two things that are truly non-material, completely non-material, which is thoughts in your brain, and that's inside your head, and then external to yourself, that is non-physical, completely non-physical, is the creator, right? It's completely non-physical. Okay.
Right.
External to ourselves, everything else is physical. Angels are physical. Just because we don't see them does not mean they don't have a physical reality in matter, right? They possess. They're constituted of something
They have
else.
space, yeah.
But they are something in the universe that's physical. It's just that you're not seen, right? That's all. So the idea of spiritual, oftentimes, it's just a hazy term that, we have to put it aside right now, because we actually do believe that all these things do possess a physical reality. Even the soul, the Prophet ﷺ said, he described it as it is a subtle substance, right? That can be connected to the body, disconnected from the body, et cetera, right? It infuses the whole body, even so much so when an amputee loses an arm, he still feels that there's something there. That's probably what the connection of his ruh that was connected to it. So we do believe even these things, the soul, the ruh, all these things are physical entities, but they're not. That doesn't necessarily mean
Subtle.
that they're composed of matter. Of physical matter, of our type of matter. Sorry, I should say of mud-based matter.
Detectable, yeah.
Yeah, but they are detectable energies.
Yeah, what I was going to say in terms of non-material things that we do believe in, outside of just your thoughts, even things such as it's like feelings, right? They might not necessarily be thoughts, right? Those are intangible realities that we feel. For example, someone can speak to me without words, right? Whether you hear a nice poem or you see a sunset, or it's someone's, for example, somebody saying that he spoke to me, in volumes, but it wasn't through speech, right? It wasn't through.
So you talk about meanings.
But you can also
Meanings, right.
You can also argue that your feelings have some root in a biological response, right? Like somebody could like a biologist could say that, hey, you're feeling happy because there's certain chemical signals that your response to some stimuli produce some chemical signals in your brain that gave rise to the feeling of happiness, or that the feeling of sadness, or that your thoughts are manifested in the firing of some neurons in your brain. So those things could still have a root in physical reality, even though the thing itself, right, the feeling itself or the thought itself might be an abstract thing.
And of course,
it has a origin point in some
relationship.
Yeah, right.
It's like like magnetism. In fact, the Prophet ﷺ spoke about used the word jubilat, like it's created too.
Yeah.
So we're created to feel love or happiness when someone smiles at us, right? Or gives us something nice. Even the Quran mentions the color yellow, that there's a natural created response to be happy when you see the color yellow, right? In things.
Yeah.
So that's why it's used by, things for children, etc.
You mentioned biological processes. If I'm not mistaken, there are, leading neuroscientists that do believe today, that it is not ourselves, but really, neurological processes that have determined
Your decisions,
our
your
thoughts
choices.
and decisions and
Yeah, yeah,
emotions. I don't necessarily agree with it, but this is a claim that people have, right?
Well, what makes sense is that these processes are determining us in a set. So if your nature and your temperament is in a certain way, that you'll be really affected by certain external stimuli more than others. This all makes sense. It's sort of common sense. Like, for example, some temperaments are more attracted to beauty than they are angered by harm. Right? If you think about, these are two stimuli that are common in the world. So others are the opposite. They could care less about the beauty, about reacting to beauty, and more about setting order to disorder.
That also leads into like what you're saying. If all of according to some neuroscientists, if all of your decisions, choices, emotions, if all of them have some biological root, some chemical basis for that, then essentially they're saying that if you had, not saying that we have that information, but if you had all of the information that you knew, all of the inputs that went into making a certain decision, and you knew you had a complete picture of all of the processes that lead you to make a decision, then if you have knowledge of that, you can essentially predict like what you might do given a certain situation or presented with a certain
Isn't that what you were saying earlier?
Yeah.
Tell us about that.
So it's kind of like, we are all collection of trillions of particles, right? From a reductionist point of view, each particle is described by a set of equations in physics or math. Now, in principle, the behavior of the collection of particles, in principle, if we believe in these equations, it's in the solution of these equations, right? It's just that we cannot we cannot solve these trillions of particles and how they interact. Excuse me. At the same time, so the current, this is in my view is also a belief, is that all the emotions and thoughts and all these things, it's just an emergent property of billions of particles. But then again, this has to be rigorously proven. There has to be more.
It's an
rigorous.
assumption.
That's a working assumption. Just as I said, the space-time, matter-energy those are the basic elements for working assumption. That doesn't mean other things are not there, and in future will not introduce other quantities. So the current understanding is that the life is an emergent phenomena of a collection of particles, for which we are trying to understand the detailed behavior of the particles. So then if we solve these trillions of equation, we'll be able to tell
Reliably
the difference
predict,
between, animation or inanimation. But then no one has really
We're not
done
even that
that
close.
from
Yeah.
the quantum level up. I mean, it's that is a that is belief in the scientific world, but
Right.
one has to really
One
do
thing,
that. And on the way, there may be surprises.
Yeah.
I don't know.
one thing that forecasters is always try to. You can never predict human nature. I remember, and that is like
There's some irrationality built in. It's not.
that's exactly what we're
Yeah.
saying. And
Yeah.
you had mentioned earlier
Yeah.
that at the quantum level, that one of the
Many
definitions,
weird things are there.
that there's a purposeful randomness to it. That it's not random because we don't know about it. It's random by design. And if you think about it, that the economic predictions are very rarely correct, right? Predictions of wars have been very rarely correct. Predictions of anything related to the human being, I mean, it's a crapshoot, right? I remember reading Thomas Friedman, the New York Times guy, who a couple years back published a book. He said of the economists who predict stuff, he says economists, it's a complete random field. Whatever they predict is not going to be correct. It's like 1 out of 100 times will be correct. And he said the last 10 economic failures, massive nations that went down, or massive collapses of nations economically, he said we only predicted one. Right?
Some of
Out of 10.
some of these predictions depend on the assumption that most of the people at the individual level, they're taking rational decisions. But a lot of the time, you can be rational in one way, but irrational in 10 different ways. You can do 10 different weird things
Yeah.
that is not the right thing to do. You can
Yeah.
do wrong in many ways.
Yeah.
So then, when these economic models involve psychology
Right.
of mind, that has to go into that
Yeah.
modeling. But it's not easy to model psychological irrationality of mind bring that into a real economic analysis. But that is affecting at the ground level.
To give you a perfect example of this
Yeah,
with,
yeah.
with a little bit of comedy, I used to have a coworker, during the time of the election of, our current president, this guy, he was really big Democrat, and he was like pro Clinton all the way. And, he was talking about it for weeks and weeks and weeks. And the day after the election, he comes into work and he was like, guys, I voted for Trump. And then we were like, but why? Like you were like this pro-Democrat. And he's like, yeah, but he's like, I've been stressed out about work. I've been stressed out about all these things. And he's like, I just went into the booth and, he's like, I just sat there for, 15, 20 minutes. And I was like, you know what? Let's make America great again.
Yeah. That's a very common thing. I mean, you were talking about like the irrationality of the individual agent in
10 different
economics,
ways, right?
but
Yeah.
like something that's a very clear example of that is having kids, right? Having kids in America is a very financially risky proposition, right? Having a child is probably economically, if you would ask the economist, it's a bad decision, right, for your finances. And yet people have kids all the time, and they willingly choose to have kids. So like that's an example of something that's an economically clear, differing from what somebody might make as a irrational quote unquote decision.
Because-
What makes it more irrational is that 10 different ways people take irrational decision. It also has variation over ethnic groups and
Right.
and cultural microculture and all these things. So modeling that in a reliable way
It's impossible.
is
It's
very difficult.
And I mean, economics is like one factor. So people might like want to be happy.
Right.
It's So, but
But
curiosity.
then the definition of happiness also has
So it's
cultural.
completely subjective.
Right.
And it's a lot of it is the what if effect. Like you said, the guy who went in and voted for Trump. Well, Trump modeled his campaign. People don't know this. Trump modeled his campaign on Jesse Ventura's. Because Jesse Ventura won by if you remember Jesse Ventura, the wrestler, when he went out, it was a joke, right? And then he trounced everyone. And the reason was everyone was like, well, what if a wrestler became governor? Like, what if, right? So human curiosity is a factor that I don't know if many even animals possess curiosity. How do you even measure curiosity? Like, curiosity is one of those things that's part of our irrationality and randomness, is we get curious about different things. And if you look at human beings, their internet has shown us how curious human beings are, right? Like, very stupidly curious. It leads to a lot of injuries. It leads to a lot of stupidity. It leads to a lot of crazy things that now that we have the internet, we can see how crazy people are, because we have, certain things like fireworks and whatnot that people are setting it off in different ways. You get to see and cameras that can capture what people are doing. That curiosity is one of those factors that you also can't measure.
That's why I think it's very interesting, especially when you get into the world of physics and science, that you're not, when it comes to human beings, right, whether it's the liberal arts, and when I studied economics, the problems with studying those science, I don't know if you can even call it a science, but what the problem with studying economics or these theories is, it's very different from the world of physics and math.
Yeah.
I'm in the world of computer science. When I write, the other day at work, we ran into a problem and somebody was like, no, but it shouldn't, it needs to do X, Y, and Z, and they're like, for some reason it's just not doing X, Y, and Z. Maybe we just need to turn it off and turn it back. I was like, that's not how it works. It's a machine.
We're superstitious.
Right? Like, it's like, oh, maybe you just need to try it again. I was like, that's not how it works, right? These are equations, and there's certain algorithms that we've written. If unless there's a mistake in the algorithm, it will only do what we have told it to do.
Yeah.
Right. And so the world of physics is very similar, right?
Yeah.
It works based on mathematical principles and standards.
And the uncertainties have laws. As I
Correct.
was saying, that the laws of uncertainties are actually deterministic. There is no randomness in that.
Correct.
Laws of probabilities.
But that's where I find it even more so interesting, the fact that you have many physicists that deal with things that affect people at a very personable level, especially things like cosmology, especially things like the origins of the universe, the origins of what it means to be human, the origins of time and space and existence and reality. So how do you reconcile that, especially as a Muslim professor of physics at Princeton, understanding, is there ever this, do you have like a dichotomy, like, hey, here's my world of theology and, my belief system on the left, and here's my world of physics on the right? Like, tell me a little bit about that.
Yeah, I mean, as I said in the beginning, the physics is a discipline, and as I said, it's about trying to understand space, time, matter, energy. But then, how these laws of physics connect to social laws or psychological laws or neuroscience or human behavior, there is a huge scientific gap. I'm talking about, if you say belief system or religion or cultural anthropological traits, to scientifically connect, there is a huge gap. I mean, as I said, you first have to understand the connectome network of the brain and how that connectome network of the brain connects to other individuals, 10,000 people, right? So this is an enormous gap in science itself. So then, in my view, these are, in some way, it's probably thousands of years later when we can reliably connect to these things in a reductionist way. So it's about it's about how people lived 5,000 years back. I mean, they knew, they had a view of the world. Maybe they thought the sky is like where the gods live or whatever. I mean, so how do you know 5,000 years from now what the science would be? Will science be able to connect to this? Let's say just the brain connectome network that I was talking about, just at an individual level. But then how those networks connect at the social level, 10,000 people share a belief or share a thing and put it into action. Understanding all of that in a scientific basis is way far into the future. And that's how I believe. I think of it as unfinished task of science, how to interpret cultural anthropology. Religion is part of that cultural anthropology. It emerges at a social collective level of connective networks connecting in some way.
Now, when we were talking about the free will discussion and the experiment to try to determine whether or not an action takes place in some brain activity first and then the action takes place, or vice versa, or
Yeah, as far as I know, I mean, I'm not an expert in neuroscience, but as far as I understand, it's kind of inconclusive. There is room for more research.
Okay.
There is a
Now-
consortium being formed that they want to look into it from a scientific point of view. So the fact that they want to look into it, that by itself tells you that it's unsettled.
Unsettled.
Not
Now-
fully settled.
Yeah. So certain fields do come upon ethics, right? Now, this might not. This is just like a neuroscience experiment. But
Yeah,
Oppenheimer, for example, when he made the atomic hydrogen bomb or whatever. But so that brings up the subject of a lot of things can be done, but should they be done? And that goes back to the individual. Now, you can say, people often say, for example, in politics, you have to separate your religion from politics, let's say hypothetically. You separate your personal beliefs from your politics. This is a phrase that's really almost, there's problems with this phrase because you can say that phrase, but you still can't separate the ruler or the governor or the politician from himself, right? You can't separate him from his own beliefs.
Yeah.
So you're still going, from a Muslim perspective, you can say separate religion from politics. Okay, but you're still not separating the Muslim ruler from his Lord. You can never separate that. He's still going to ask him why you did X, Y, and Z, regardless of. Likewise, in the field of science, this comes that same ethical question where you can stay, let's separate science from everything else and be purely objective. That's just a phrase. You still can't separate the scientist who's doing the observation and moving his hands and his body to do the thing. You still can't separate him from his beliefs. Even if he claims to have no beliefs, he does have preconceived notions, right? So you still cannot separate the scientist from himself in the same way that you can't separate the ruler from himself and his preconceived notions and views, et cetera, et cetera. So I don't know, in your field, you may not come across this, but obviously Oppenheimer, for example, did. He produced the machine, the bomb, then really regretted it, right?
Right.
So those types, that's obviously a
I
extreme
don't
example.
think the discipline, physics itself,
Doesn't touch
the
upon-
laws of physics are not, it's not giving you moral decisions, or just as the laws of you encounter in biology is not giving you moral decisions directly. I can give you one clear example, like survival of the fittest. So let's say if you take social Darwinism, the fact that this is operating in the or the belief to be operating in the biological world. Now that's part of science, right? I mean, if within science itself, I'm not going out of science. Now, if we were to take a moral lesson out of it, should we form our society reflecting that? Because the species have been successful by operating that strategy, survival of this. So we're not always taking ethics or moral from the science. There is a danger to it. I mean, nobody will
Yeah.
agree that survival of the fit, then it will lead to anarchy if you apply that to human species. We have artificial laws, then that laws are not consistent with the law you observe in nature, that lion has its own ecosystem and how it survives in the wild.
But
Learning it, I'm not sure if learning ethics from science is useful, or whether there is
Yeah.
a basis for it.
But certain subjects, scientific endeavors do involve, for example, that's the question of, do we have free will in an experiment to
Or
determine
genomics.
to experiment to determine whether or not we have free will or not? That's something that, let's say, me as a Muslim or you as a Muslim, immediately we have an answer to that. So the way we go about that experiment would be more like, it wouldn't question free will. You wouldn't be able to do it. I'd be denying myself if I even propose that that's even a possibility, that whether or not human beings have free will. For us, that's not a question. That's because of our epistemology, tells us revelation first, logic second, observations third, right? Revelation has already told us that human beings have free will. So now, for me to even probe that question would be a conflict in my personal epistemology. And what I'm saying is every scientist has an epistemology. He can try to deny it as much as he can, but we as Muslims, for example, do, Christians do, even an atheist will have some certain beliefs, right? That he will not go into those beliefs, right? For example,
Contradict.
he won't. For example, No physicist will ever engage in a study to see if one ethnic group is essentially inferior in some field, right or wrong. They won't even do it. The university won't even allow the discussion to take place, right? So what is that? That's an external meaning and belief that's affecting the way science is done, right? No one will go and say, let's go and see which ethnicity loves, power more, or where is power coming from in the mind. And let's see, my hypothesis is that this ethnic group loves power, and this ethnic group, et cetera, right? So just in the same way that we can understand that, question will be thrown out the window. Likewise, certain things for Christians will be thrown out the window. Certain things for Muslims will not even be discussed, or it will be discussed in a different light. Right? Does that make sense?
I'm not an expert on those topics to.
But do you get the idea that there are beliefs? Every society institution does have
There's certain axioms.
sacred cows, right?
Yeah.
And that will affect how the scientist, what he will ask, right?
Yeah.
That will affect what we ask. Like no scientist can come in today and say, well, let's do a study and see and ask exactly why certain ethnicities excel in this sport and others excel in rational topics and others excel in economic topics. It's completely racist, right? It'll be thrown out the window. But I'm sure other civilizations have totally accepted it, right? So just as we can understand that sacred cows affect how science is actually done, the questions we're allowed to ask. You're not even allowed to ask the question. So likewise, certain question on like free will. We might still do a study, but the idea that free will might not exist won't even be allowed into the discussion, in the same way that a racist study won't even be allowed, whereas in previous civilizations or maybe even future civilizations it would be allowed.
I think I'm getting to the end of my questions here. Is there any questions that Saad, you and Dr. Shadi have?
No.
Let me think if I had anything. Yeah, one last question. Very interesting. What we studied is that, or what we discussed is the Big Bang, right? The Big Bang did contradict one of the basic fundamentals of physics. Could you expand about, what that was exactly?
Yeah, I mean, Big Bang is it's that Big Bang scenario. Physicists believe that there's a number of experimental evidence for it, but the actual point of Big Bang, at the zero of time when the universe came into existence, this is also mostly understood by physicists that there is a lot more to be understood. I mean, it's an unusual, exceptional point. So the laws of physics, the way we know it, because we can do experiments only around here, probably with more detailed experiments only within the solar system. We cannot go further out and test whether the laws of physics or laws of nature are different. We don't have absolute proof for that. As I said, that it's mostly about believing repeated, reproducible experiments. So, so Big Bang there's a general belief that the universe came out of a singularity, but the nature of singularity and what the laws of physics, how it operated there, there is a lot to learn about it. I mean, we cannot say definitely. It's not. I don't say that. The Big Bang part is a very exceptional case. I mean, the earlier things we're talking about nature of quantum particles, we can do experiments and figure out, right? But in case of Big Bang, we cannot create a Big Bang in our lab and figure out how the universe was created. So we have to speculate a lot of things. So we are aware of that. We have a lot of speculation about it, and so I mean, there is a lot more to learn about it. But what is interesting is that in my view, unless we actually create a Big Bang in our lab, we cannot talk about the level of certainty. We talk about other things like microscope and accelerators and other things. So
physicists don't use analogy.
yeah.
Right? Like if this happened, then therefore this must have happened a
Yeah,
lot.
I mean, there is analogy, there is extrapolation and interpolation, but then figuring out if real, truly fundamental law of physics, one has to be really thorough and careful,
Yeah.
and it requires repeated observation. So that's why it's difficult to answer a lot of question in a very definitive way,
Yeah.
what happened near Big Bang or at Big Bang.
Yeah.
Because we may never.
But the idea of equilibrium.
Yeah,
was
the
not
fact
absurd.
that the universe is expanding, there is plenty of evidence for that.
Yeah.
It's that, and not only that, the expansion rate is increasing, meaning it's accelerating. And then if you backtrack, then everything goes back to a singular point that is understood. But what was the nature of that singularity?
Yeah.
It's very speculative.
Okay, good.
I've always had one question, and we can cut it right after this, but around the expansion of the universe, right? So if the universe constitutes what we consider space and time, right? Meaning, like, let's say this room, or let's say in an analogy, like a balloon is the universe, right?
Yeah,
and it's
yeah, yeah.
expanding. Well, now the balloon exists in a larger space that it's expanding into, right? If it was enclosed into some, enclosure, it couldn't expand any further. So if the universe is expanding, right, then what is it expanding into if there's no space outside of the universe?
Right. So it's this is a good question. It's like the balloon analogy is good, but in 2 dimensions. Let's say you have the balloon, and the space is not 3-dimensional. So let's say the surface of the balloon is our universe. So that means, let's say there is an ant on the balloon, and the ant cannot jump. It doesn't know how to jump. It's always confined. So the balloon is expanding. So then this question, and then the balloon, the expanding balloon, itself defines all of space for it. So then universe can be finite, but there is no boundary. So if there is no boundary, then you cannot fall out of the universe. So it's but when you take the balloon and think 3D space, then of course the surface is the boundary. But if the space is 2D only, it's expanding. That's all of space. But then the ant can only walk around and maybe even come back or something, but it's still confined to the universe because so
It
that
can never
means,
get off the surface of the balloon.
Right. So that means if there is no boundary of the universe, then that question doesn't again arise. So in other words, something can be finite but have no boundary. So when you ask that question, the thinking was that if something is finite expanding, then there must be a boundary, you can fall out of it. But the topology or geometry of the universe could be such that something is finite but no boundary. These things exist in geometry or topology.
But
So it's not necessarily the case that universe has to expand in non-space something.
Right.
So that geometrically it's allowed to have a finite object with no boundary.
And it's almost impossible for human beings to conceptualize non-space and non-time.
Right.
So that question is a really interesting question. They always draw like the universe, like
a
expanding,
donut?
Yeah.
or a trumpet, right? Like this.
Yeah,
They draw it like that.
Yeah.
But they just color black all around it.
Yeah. But this is because in 4-dimensional
projection.
space-time, you cannot show that non-boundary. I mean, it's the example I gave that for if you think the ant's universe is the only space, and space is only 2-dimensional, or it's on the surface of the sphere, then that sphere has no boundary. I mean, the ant can go around it and it's expanding, but then it cannot fall off. It's because that's all what exists. So a finite object can be boundaryless. So this drawing, since it's trying to draw the projection of actual at least 4-dimensional universe, then it's difficult to draw that. You can only draw that in 2 or 1 dimension. Or Mobius strip is another example where
Like this?
What would be a one?
the
side
system.
list.
Yeah.
What would be a one-dimensional drawing of the universe expansion? Just a straight line.
One-dimensional drawing of.
Well, 3D and time is the fourth dimension. What's the
No,
fourth dimension?
time is a different dimension, but I'm talking about space. So
Just be a point, no?
the one-dimensional universe. Yeah, I mean, you can expand in a line, but then understanding that geometry or topology is easiest in two dimensions, the surface, because the surface has no boundary. If the surface is the entire universe, then there is nothing to fall out of. It's just that the space is expanding.
So it's like, for example, like
Meaning that the 2 points, two separate points, the distance between 2 points keeps increasing.
So you would just keep going almost
so it's like if we were standing, as if we're standing on the Earth right now, locally, it seems like a flat space, right?
Yeah.
Let's say we didn't know that we were on a globe,
Yeah,
right?
yeah,
and
yeah.
locally, we feel like we're on a flat plane.
Yeah,
and
yeah.
let's say the Earth was just getting bigger. If we just kept walking
It will
straight,
look more and more flat.
yeah, it would just look like the flatness is expanding.
Yeah.
But really, the globe is getting larger.
Right.
Okay.
which means that the universe is must be of a circular,
spherical. In higher dimensions, it can have more complicated geometry or topology, but something like that is happening. I mean, we also don't know exactly what its topology is. I mean, I gave a mathematical example that it is possible to imagine in geometry that some object can be boundaryless, but still finite. When we think something something non-infinite, then we think, let's say infinite line, then we don't know the boundary. Boundary is a plane. But when you say it's finite line, then these are the boundary points, endpoints. But it's possible to have a geometrical shape that is finite, but it has no boundary. So as I said, the surface of the sphere is the example. But in the real universe, it's
be
hard
on
to
the
imagine
fourth
because
dimension.
it's in the four-dimensional geometrical,
Makes sense.
and
Right.
maybe even more. I mean, some
Yeah.
theorists believe it's maybe even string theorists believe it's even more 10-dimensional or something. But I'm saying that it's logically or mathematically not insane. It's allowed to have an object that has no boundary.
Okay.
but okay, it has no boundary.
But
in
finite. It's infinite things, there's no
Yeah.
boundary, but finite object can
We know
be
that
of
about,
no
but
boundary. Yeah.
no boundary as per our experience of it.
Yeah.
But
But
then-
again, it's
Okay.
within the physics
Physics.
realm,
Yeah.
right? And now you could say that, okay, that ant, which lives on the surface of the sphere, somehow it developed a sense of a third dimension.
Yeah.
Then it doesn't have, then everywhere there is a boundary.
Right.
It can leave the universe from any
From any-
point.
Yeah.
But see,
Right.
yeah.
So some people may want to say that if they're claiming, quote unquote, they're leaving the universe,
Yeah.
they figured out that hypothetical third dimension,
Yeah.
like
Like jumping off the balloon.
they can leave the universe from. They don't have to travel far away to find boundary and fall off the universe.
Mm.
They can leave the universe from any point at any time.
Yeah.
It's about figuring out how to jump to the third dimension, a new dimension that is physically not confined. But then whether that sort of dimension exists or not, we don't know, or
we don't
whether
know
that
about
we
that.
call
Yeah.
non-physical experience, that also we don't know. We have to do experiments
Yeah.
to figure out.
So I understand the ant on the balloon idea,
Yeah.
but as per our universe, we do move in those three dimensions. So
Yeah,
we
yeah,
could
yeah.
go out. So if you were to send,
So then you have to move to the fifth
Fourth,
dimension to
What
leave
is the fifth
universe.
dimension?
I don't know. I mean, whether that
okay,
exists
so
or
they had
not.
to say there.
Yeah.
Because I'm thinking myself, like Sat's question. It sounds silly, but really, if you think about it, knowledge is gained by asking questions, right?
Yeah.
So if you were to take a rocket ship and you were to just keep going in one direction, right? One direction,
Yeah.
all right, up.
Yeah.
Just go straight up.
Yeah.
How would the ant analogy work? Because you
So-
would
so-
have
We're
to.
just traveling.
So then
on the balloon.
traveling around the globe is expanding, and you cannot travel faster than light. If the globe is expanding faster than light, then you will never come back to that point. But if you can travel, if the globe was not traveling faster than light, I mean, the universe was not expanding faster than light, then you could come back to the origin and go
Let's
back
Yeah.
to the past. or
So it's
some
expanding
thing.
faster than you're ever gonna go.
let's see if I understood it correctly.
yeah.
Because in the ant example, let's say it's this rocket ship. Even though this rocket ship could take off, you would never ever reach the end because you're just going to go around this balloon. Like
This,
Yeah, yeah,
the
yeah,
same
yeah,
way
yeah.
the ant is operating in the two-dimensional surface of the
Yeah,
thing,
yeah.
we're operating in the three-dimensional
Right.
space, right? So it's
Space.
taking a rocket into space is the same as the ant crawling across the
Right,
balloon and never
precisely,
getting off the balloon.
precisely,
Which,
precisely.
which means that we are assuming that there is a third dimension or fourth dimension, which we're just not aware of.
Yeah,
Fifth dimension.
maybe.
Yeah.
Yeah, so that means you would go up, and then years later, we say, oh, look, there's Earth. That's what you're saying? Because that's exactly what the ant's analogy is. He's walking, he passes by
Yeah.
a tear.
Oh, like we would come back, you're saying?
That's what you're saying, that's,
Yeah.
that's what the ant thinks
You
never
can
lives.
come back if you
Go
if
straight.
you're you go straight, but if you can travel faster than the expansion of
Of the universe,
or
yeah.
if that is faster than light, then in physical universe as we know it, you cannot do
Then
that.
that's impossible.
Yeah.
So if the universe
that way
is
you're-
expanding faster than
Yeah,
light,
so the
and
current-
we can't go
the
faster
current-
than light, we can never
The,
get
the,
to
the
that
current
point
belief
again.
is that shortly after Big Bang, the universe expanded much faster than light because that does not violate relativity or anything because that's the space itself expanded. I mean, the light is a physical object inside the universe. So the universe, the
Must
current
have-
belief is that it expanded enormously faster than light and the universe became enormously big. So then now you cannot go around.
Okay, now another question. I know Moeen wants to wrap up, but I have another question. This also goes back to, physicists are human beings that do have certain beliefs, and they have a discipline, and they have beliefs, and everyone wants to reconcile, or sometimes come up with some idea. What are your thoughts on the story of the Prophet's night journey and the Buraq, and that he went and there was a door, right, a gate, and then the angel Jibreel knocked at the gate. Then that gate was opened up, and he said that there was a world, far greater, right? Like the difference between a ring and an entire desert. Then he did this a second time, right? And then a third time, and a fourth time, and a fifth time, and a sixth time, and then a seventh time, right? And each one, relatively, like this universe was like a ring in a desert. Right, and then the next universe was like a ring in a desert, and so on and so forth. So you, as a Muslim who have heard this story, and you're a physicist, I'm sure in your mind something must be going on that's very different from everyone else's mind who's not a physicist. So can you just give us what kind of ideas that go through your mind when you hear that type?
Yeah,
of
I mean, again, as I said, that the physicist's real thing is whether you can do some experiment and reproducible thing, kind of find an effect, and only then you believe that, right?
Yeah.
So this type of description, to me, I mean, personally, it's not based on physics. I mean, it sounds like kind of like finding access to additional dimension, and if in physics we haven't found such a thing, right? And if somebody in some anomalous way found some access to additional dimension and travel in extra dimensions, I don't know. I mean, to describe that in physics, then we have to find some analogous thing and do experiment to figure out what is the law of physics in that strange dimension.
Yeah.
So it's not mathematically, in my view, impossible that you can
Right.
have strange dimensions in the
Yeah.
universe, but whether that actually happened or not, a physicist cannot tell without
Yeah.
doing further experimentation.
And then-
but it's not, one cannot rule out
Yeah.
the existence of other dimensions.
And then if you open up that possibility, then it opens up the possibility for so many other things. If you can pop in and out of a dimension,
Yeah.
then there's so many
So
other
it's similar
other
to that.
things.
You can leave the universe.
Yeah.
In the ant analogy, you can leave the universe from anywhere.
Yeah.
You don't have to travel long
Yeah.
distance. I mean,
Right.
anywhere
Yeah.
from the universe.
Did you see the movie Interstellar?
No, I missed
It's probably silly for you,
Yeah.
but it's the idea. It's about a bunch of ideas about dimensions and time.
Yeah, there's a lot of fiction that, I mean, I read a fiction, I don't remember the name exactly, where they found a warp in space-time near the ring of Saturn. And so
That
you
is
could go on a hyperdrive. So in other words, you could there the space-time, there's a singularity. I mean, there is no reason that you cannot have random singularity. I mean, although we haven't found any, but nothing is ruling out. So that science fiction is based on that. So you enter that, and then you enter and through the wormhole, black hole, you enter the other universe.
Yeah.
So then you bypass space-time. So then in other universe, there are many dimensions. So you have all those miraculous journey, like time is not moving and all sorts of things. So it's a sign. To me, the Mirage description looks kind of like that science fiction description where you entered a new dimension through a new universe, and then at that universe there are so many layers, and there are different laws of physics operating, different creatures, the civilization doing strange things.
And that kind of goes back to what Dr. Shadi's point was initially, is that even what we think of as like spiritual experiences, they have some root in matter. Yeah, mm-hmm. and that's quite possible.
And my question was then, like when a lawyer comes upon a verse or a hadith, he thinks about it from a legal perspective, right? Mm-hmm. That a common person might not ever come across that. For example, let's say in economic ethics or ethics of trade, there's a hadith that says the city dweller shall not go out and sell to the nomad, right, to the Bedouin. Right? And many people are like, why? But the reason is that the Bedouin therefore has no clue about the prices. He's cornered on the prices. Right, so so the Bedouin it's obligatory that the Bedouin must be able to see prices. It's unethical then for to go out to the Bedouin and disallow him from seeing the prices market price and say, I'll only sell you, this is the sale, here, take that. You're fooling them, right? You're taking advantage of them. So no one's going to think about that commonly unless they had some basics in, buying and selling and the ethics therein. So that's why I asked that question, is that you have a different insight than most other people. So the question of the Mi'raj, that type of question, I'm sure you think about it in a different way, than most other people. Mm-hmm. With these, it's just so hard to imagine dimensions. Mm-hmm.
Not just the Mi'raj, right? I mean, there's other examples. I can't think of the hadith right at the moment, but there is a hadith with. I want to say there. I think Umar radiallahu anhu said it. In another, there are other Umars.
Oh, Ibn Abbas.
Ibn Abbas, sorry. Yeah, Ibn Abbas,
so it's not like a strong base statement, but it does exist that Ibn Abbas said there are many universes, right? Or there are other worlds, and on that other world there is another Ibn Abbas, right?
I see.
And another, So
it sounds like
yeah. So I'm just thinking, like, from a physics mind, you probably have a different view of those hadiths than us, where I usually relegate things that are in the unknown, it's in the unknown, like it's completely unseen, and there's no point in commenting on it, because anything you're going to speculate is not going to be right.
Right.
If it was right, then
Yeah, well, as I said, one big constraint in physics, you don't want to believe in something too strongly unless you can do reproducible experiment. It's not just one description that you can come up with some theory that may describe it, but a real physicist would like to do a repeat. This is also why Big Bang is also a mystery, that we cannot create a Big Bang in the lab. So we are careful about what we want to believe about Big Bang, right? I mean, we can only say very limited things. Mm-hmm. So these things are, in some way, it's similar that you can come up with certain explanations, but unless you have repeated experimentation, and then you come up with some explanation, and then you have a falsifying test, only then you believe it. Believe it in a scientific sense. I'm not saying that there is no truth beyond science, but science has its own methodology.
Or explaining it.
Explaining it.
Yeah. So you might believe in a lot of things, but you have no clue about that.
Yeah, it's like many people have explanation for UFO, and they're self-consistent, they're logical and mathematical, but then and there are many self-consistent mathematical and logical explanations of UFO, right? but then which one is right? So since just that something is mathematically consistent and it doesn't mean that we have handle on, we know the real truth. So the real truth is then if this is so, then can we do do something with the UFO and try to probe it this way, that way, and then its response conforms our particular model. Only then we'll believe in that model as science.
So just to clarify, you're talking about the explanations of the phenomenon.
Right.
All right, good. Any last questions?
So no last questions, but since we're at the end and we said we can go on tangents at the end. So did you guys see the thing that released from NASA? Sorry, not the NASA. From the Navy. That there was a unidentified UFO.
I did see that.
Yeah,
I
saw it. I sent it to you.
So there was there was actually a Joe Rogan episode where he actually had the
fighter pilot on there.
Yeah, the fighter pilot on there, and he explains how he saw this object, and there was other people, and he's explaining it from like a military perspective, what training they were doing and how they saw it. So this was, I think they were about 20,000 feet up, and they saw this object from, I think, what is it, half a mile distance, something like that, and it was floating just above the water, and they said that he said that the speed at which it accelerated, right, was. He said that the fastest, like a Raptor plane is probably the fastest thing that you can.
It's like supersonic.
It's supersonic speed, Mach 3 speeds, the fastest you can get. He said it takes about 1 minute that you can, visibly no longer see the plane.
It goes off into the distance.
Like if it were to go off into the distance, you can no longer see the plane. So he called it a tic-tac shaped object that was in the sky, and he said it flew off. He said it took it 1 second and it was out of their vision.
Wow.
Yeah.
So, and it was it was just something.
Yeah, it's like a huge thing. It happened in 2004, and like the Navy just declassified a lot of the footage that they got from the sensors from it. And there's like a lot of discussion online. A lot of a lot of scientists as well are chiming in. Like maybe it was like a sensor malfunction, right? Like there's explanations for this, but like the verbal testimony from the fighter pilot is very interesting, because it's like it's hard to explain that away. You could be like, oh, they were having like a mass hallucination or something or seeing some something refracted, like the light refract, but it's it's kind of interesting the way he describes it. So
it's interesting because when you had said many times, the physics doesn't accept something that cannot be reproduced, right? Now, the funny thing is that over the years, as a person gets older, you oftentimes relegate so many things. Also, like I oftentimes relegate so many things to the box of insignificance if it has no impact on lived life, right? And no impact on my obligations as a human being, right? Which is a very comforting thing, believe it or not, right? And when you're young, you worry that you're missing out, right? I'm worrying that I'm missing out, that maybe this thing, because you're curious, right? When I was young, I was very curious about everything. So I would not want to dismiss anything because I really didn't know if there was fact behind it or reality behind it. Well, as you grow and you examine things more and more in life, you realize that certain things are purely just theories or certain things are purely experiences, positive or negative, that will not impact daily life. It's actually comforting when you deal with nasty people, right? Or nasty experiences. Like, is this experience or this person's opinion going to impact lived life and daily life and my obligations in life? The answer is no. Therefore, you cancel it out. So the idea of canceling out pieces of information or statements or stuff like that doesn't affect
cancel culture.
Yeah, I'm very cancelly, right? I cancel all the time, right? If it doesn't, just like you said, if it's not in the sense of physics, if it's not reproducible, then we're not going to use it.
I mean, it may still be real, but we cannot be definitive about it and get something useful out of it, and useful not necessarily in a utilitarian sense, it's also in advancing the knowledge. If I cannot thoroughly test and examine these things and under various conditions, then it may not be worth spending too much time on it.
Exactly. For a lawyer, for example, say, look, you got a complaint. Is it actionable legally? No. Okay, then don't worry about it, right? Doctors, same way. Nutritionists, same way. So it's also it's every discipline has its
Right.
real things and canceled things, right? So as you grow, you actually cancel a lot of things. You just keep canceling and canceling and reducing things
Right.
to the absolute necessities,
Yeah.
or not necessities, the absolute certainties, I should
Right,
say.
absolute
And that's
certainties.
actually very comforting to know what are the absolute certainties and necessities. It gives the person a lot more comfort.
It's also because as you push the frontier of knowledge, the what you know, the uncertainties become greater.
Yeah.
It's like, if there's some core understanding on a topic, and as you push that farther and farther, there's a lot more that you don't
Yeah.
know, and a lot of tangential questions that come off of certain things that you're
Yeah,
like,
yeah.
okay, now these other things are all open questions. I answered one question, but I opened 100 other
Right,
questions.
that's it.
So. And which questions am I going to focus on now, right? Like I
Right.
can't focus on all 200 questions.
Exactly. Yeah.
Yeah,
well,
yeah.
Yeah. It's like there's not enough time in the day to focus
Right.
on, and this idea of knowing your job and your obligations. One of the benefits of religion is that if you don't know, the religion will tell you, right? Your obligations in life, and then you could just focus on them. Everything else is not really gonna hinder you.
I just found the UFO story interesting.
I love the UFO. See,
Yeah.
I'm actually going to watch it. I'm going to watch the video
Watch
because
the
it is a
video.
video. It's like 3-second
yeah,
clip.
yeah.
I love these things.
And
The
they
Joe
have-
Rogan thing is like
they have
30
like
minutes.
they have the footage from like the IR sensors or like the sensors off the plane,
Yeah.
and they have the object there, and there's so much speculation around like what is it? Was it like the malfunction or
Yeah,
all this stuff?
I never
It's
read
pretty
I
interesting.
read the speculations, knowing they're speculations, just for the
Yeah.
interests of
Yeah,
it.
yeah.
But-
This one was a little bit more substantial than crackpot.
Yeah.
Like
Yeah.
And here's the thing: we trust this guy to fly a fighter jet,
Right.
But we don't trust his actual
His
instinct.
visual testimony.
Yeah, I mean, come on.
Yeah.
So I mean, he's not even saying like it was like an alien or something. It's
Right.
literally just an.
He's just describing what he saw.
Yeah,
He just doesn't know what he saw.
He doesn't know what he
unidentified.
saw. He's just saying that he doesn't know of any technology that America or any other country has that can do such a thing.
Yeah.
So I mean, he was just curious as to what it is, right? So
At some point, there were ideas that these are hidden technologies. I mean,
Yeah.
some developed
From some,
by
like,
some countries
country,
that
yeah.
it has not been disclosed.
Black
and
Ops
they're-
project.
They're probing
Yeah.
us in some way.
Yeah, well, that's the whole Area 51
Yeah,
thing.
yeah.
That's a different
When I was working living in New Haven after I quit the university there, my first job was in Lower Manhattan, so I had to drive all the way out 2 hours and 15 minutes on 95. So I would fall asleep. So I needed to get some books on tape. So I got Area 51, 6 hour set. Okay, and basically at the end of it, all of what we know about Area 51, like 99% of it is utter and absolute speculation and nonsense. Nothing went on, right? Nothing went on except one guy who speculated and threw it out there, right? So when you trace back all the sources of what was said, it all goes back to like 2 or 3 individuals who are talking nonsense, right? So this Area 51 is just a normal space where they were studying, and maybe they were talking a lot about Russian technology at
Yeah,
the time
yeah,
because
yeah.
they're afraid of the Russians, and that's it.
yeah.
So here you have this huge whole
Conspiracy
social
theories.
myth, cultural myth
Yeah,
that's based in nothing, right? Unfortunately, she had to make a 6-hour book about it, right?
but why did you continue listening?
I did it after 3 hours, and I saw her rehashing the same thing. I realized that this is all speculation.
Yeah.
Yeah, yeah.
So I think that's a wrap. This was a pleasure, Dr.
It was a
Zahid.
pleasure to take your time out.
Thank you.
Thank you
Yeah.
so much for coming. Maybe inshallah in the future we'd love to have you again. So I think that wraps up. Thank you so much, Dr. Hasan. Zahid, sorry. So jazakallah khairan. Assalamu alaikum wa rahmatullahi wa barakatuh.
سبحانك اللهم وبحمدك نشهد ان لا اله الا انت نستغفرك ونتوب اليك والعصر ان الانسان لفي خسر الا الذين امنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر والسلام عليكم.